Hi, Anthony Carruthers, Better Lesson Master Teacher Project, and here we are explaining the solution to the complex sector area problem. So the scenario is you have a cow, and the cow is on a leash that's 25 meters in length, and there's a barn. The cow is actually tethered to the corner of the barn here, and there's also a garden, and the garden has been fenced off, presumably to keep the cow from eating the food in the garden. So the task is to find out what is the area, the actual grazing area of the cow, being that now the cow is not able to go into the garden. So to do this, we're going to basically be using the sector area formula over and over again, but it's a good task because there's definitely more than one circle with radius changing at different times and just lots of problem solving to do. So the first thing we can see is that um, this side of the barn right here is 10 meters, and we were given actually in the problem that this side of the garden was 30 meters. So 30 minus the 20 here for the barn will give us 10 meters here also. So that lets us know that we have a square basically right here in this region. So this would have to be a square. And that being a square, the diagonal of that square will basically bisect that 90-degree angle to make it 45 degrees and 45 degrees. So that's important because the very first sector that we have to consider is when the cow just starts to walk this way, he'll start to feel some resistance when the chain or the leash actually hits the corner of the garden here at P. So that circle sweeps basically a 45-degree angle. It has a radius of 25 meters, and so that's why we see A2. A2 A2 is 45 over 360, so we have 45-degree angle over 360, and then times pi times 25 squared. So that gives us the area of this purple region here. Okay, once the chain or the leash does actually hit that corner at P, it continues to sweep a circle, but not the same circle, because now actually the radius is going to be shortened. So whereas the radius was 25, it's now been decreased by whatever amount this is right here, the distance from P to B. And again, being that this is a square, the diagonal of that square would just be the side length times radical 2. So you'll see that PB is 10 radical 2, which would make PQ 25 minus 10 radical 2. So we approximate that as 10.86. So just to recap, we have a circle here with radius 10.86, and it sweeps a certain angle until the cow presumably runs into the garden, or at least the fence that's protecting the garden. So to figure out the angle measure that radius sweeps, all we have to do is look at the fact that these sides here of the barn and the garden are parallel to each other, and segment BQ being a transversal, we'd have here basically corresponding angles. So this is 45 degrees, this would also be 45 degrees. Okay, so we have that 45 degrees, so that gives us A3 is again 45 over 360, but times the area of that circle, which has a different radius. So pi times 10.86 squared. Okay, from there we start to think of what happens when the cow goes in the other direction. So again, the leash or chain is 25 meters in length. So the cow has pretty much free range to walk a semicircle in this direction. Okay, so semicircle would be 180 over 360, and we're talking about the circle that has a 25-meter radius, so pi times 25 squared. But then where students have to think is even when we get to the end of this semicircle, there's a little bit more that the cow can get to graze at. There's a small sector, and for that sector, we know that 20 meters of the chain will actually be lining up against the barn, and 5 meters will be hanging over. So that circle will have a radius of 5, and there's basically a 90-degree angle that radius of 5 can sweep. So area 4 is 90 over 360 because we have a quarter of a circle, but this time pi times 5 squared. So now we just about have all of our sector areas, but since the question asks for the total grazing area for the cow, we have to remember that the cow can also dip inside of this region here and start grazing. And that's just a right triangle, actually an isosceles right triangle with side length 10. So the area of 5 would just be half of 10 squared, which gives us 50. And so finally, after dissecting the grazing area into all these different sectors in the one triangle, we add those areas together and we get approximately 1,343 square meters. So definitely a complex problem, one where students have to understand kind of the physical constraints, where it's definitely helpful to draw pictures and see things visually. So really like this problem, and thought it was a good way to put a cap on the lesson for finding sector areas. Okay, once again, Anthony Carruthers, Better Lesson, Master Teacher Project.